function pointers today, that should resolve all the questions that we might have with respect to Chapter 12. It will not cover structures, right? We've talked about that. We've seen examples of it, but that was just a look ahead. This exam 1 will not cover structures. That will be on a later time. Okay, so there's that. And any questions before we start? Lab 3, which is due this week, is on tap for tomorrow. Questions about that one? No?
So did you just say the majority of the test is function pointers?
No,
Oh.
not on function pointers. That will be covered on the test. There'll be some questions about it, but since we don't have a lab with it, and it's coming very late towards the exam, it's not going to be heavily on the exam. The rest of Chapter 12, heavily on exam, in particular, dynamic allocation of memory, and pointers and passing pointers around, passing pointers by pointer, passing pointers by reference. All of those kinds of things are perfectly legitimate as far as I'm concerned. Chapter 12 is a rather large, long chapter. Just finding the end of it is problematic.
Yeah, we've been looking at it since last year.
Function pointers. It's sometimes difficult to get a handle on why would I want to do function pointers, why would I be concerned with it, what are they, and so on. And so I brought an example from my assembly class in which I asked students to write a program and use function pointers in C and combine that with some other stuff. So that reinforces it a bit, but function pointers are really very important, and they're really fairly straightforward as far as concept goes. Where it gets a little dicey has to do with the syntax, in my opinion, with function pointers. What is, let me take a step back here, what is a variable name? If you're in the assembly class, you know that right off the top of your head, okay? So Tyler, what is a variable name?
A variable name is the location.
Is a location. It's a symbolic for an address, but a variable name and an address are synonymous. They are one and the same thing. Is that clear? Specifically, an address and a variable name are one and the same, and we see that with pointers, right? We see that with pointers. So we can take the address of something and assign it to a variable, and that the address of something is, turns out, that variable name. If we remember that a function name is also a address, it's as simple as that. A function name is an address, and therefore it can be treated in many ways like a variable, except when we get there, the kind of data that we find at that location isn't data at all, is it? It's instructions. And so we don't want to try to assign something at that location. So if we remember that a function name is actually an address, the start address of a block of code, that makes function pointers a lot easier to work with, I think, if you remember that key component. So function pointers are variables. Here we get into a double level thing. A function pointer is a variable, which is an address. A function pointer is a variable that holds the address of a function, right? Just as with dynamic allocation of data memory, we get an address. A regular garden variety pointer holds the address of some other variable, right? Now we have to type each of those pointers, don't we? We can't just have a generic pointer, or it's not appropriate, it's not very good to have just a generic pointer that points to any old kind of thing, because we don't know things about size and so on. Same is true for function pointers. We have to know what kind of a function we're pointing at. What kind of a function? What are the things that make functions different from one another?
Return type?
What is it?
Has a return value?
Return value is one of them.
And parameters.
What else? Max?
Parameters.
Parameters. Can you be more specific than parameters? You're right.
What's passed to it?
Well, parameters come in
Arguments?
a lot of different flavors, don't they?
Yeah.
How many of them are there? Is there one parameter, two parameters, three? How many parameters are there? That's one issue. Issue two is, what is the data type of each parameter, right? If you looked at the prototype of a function, or if you looked at the function signature, then that becomes real clear. Function signature has a return type. It has a parameter list, and that parameter list details how many parameters there are and the data type of each one. Okay? So we have to designate that when we define a variable that will hold the address of a function. So it can't hold the address of any old function, but it can hold the address of a function, in this case, in this example, of a function returning void, right? Its return type is void, and no parameters. That's what fn underscore ptr1 will hold as the address of a function that returns void, nothing, and has no parameters. The definition for that looks kind of like some other things, maybe. But notice the presence of this parent and this one. Normally, when we define a function, we don't see those parents there, do we? Normally, we don't see the splat either, okay? Unless we associate that splat with the return data type or something, a void star. So fnptr is the name of the variable. The type of the variable is, one, a pointer, right? Two, a function. That's those two parents there. That tells us, number one, it's a pointer to a function. But that's not enough. Now we have to look outside the parents, here and here. So we look at this business, this piece, and this piece. So it's a function. We're pointing at a function. We know that by the splat and the inner parents there. that is pointing at a function that returns a void and a function that has no parameters. This one, fnptr3, is a function pointer that returns, a function that returns, can hold the address of a function that returns, an int, and one that has two parameters. Is it two? No, three. Sorry, three parameters. And it must be in this order, by the way. Can't be any old mixed up order we want. It has to be in this order. Int, double, and char star. Right? Character array. Fn underscore ptr3, if you try to assign it the address of a function that does not meet those requirements, you'll get a syntax error. Is that clear? All right. Any questions on this slide? Okay. And that's what that slide describes, and so on. Look at this strange notation. What is the data type of the thing that we are allocating? What is the data type of the thing we are allocating?
A int.
What's that?
A int.
I'm sorry?
A integer.
An integer? No.
A double star function pointer.
This thing here tells me that it's a pointer to a function. Okay? I'm allocating space to hold a pointer to a function that returns an int and has no parameters. Is that clear? And on the left-hand side of that assignment, we've got the double splat. Why the double splat?
Because it's a pointer to a code.
It's a pointer to a pointer, isn't it? Of a function that returns an int and has no parameters. Here's an array of 5 function pointers. An array that each element in the array can hold an address. But not just any address, but the address of a function that returns an int and has no parameters. They all have to be the same, right? That's traditional, typical definition of what we mean by an array. All of the data types in there are homogeneous. Clear? Okay. Like arrays, there's name references, beginning address, functions, name references, its beginning address. Okay. So here we see some example code. What's assigned here? What is getAge? Is it a variable? Data variable? Nope. It's a function name. It's a function name. Therefore, since it is a function name, it has an address where it will occur when it's loaded, right? When it's running. So the address, right-hand side, notice that we don't take the ampersand of, because a function name is an indirection anyway. So assigning this into here, now fnptr points at getAge. GetAge. Is that clear? Once again, no parameters and returning an int. Here we have the same example, making this assignment, getAge into fnptr. Now we actually want to call the function. We want to call it. So in this case, we are calling getAge and catching the return value of it in age. Doesn't look like we're making a function, or maybe it does look like we're making a function call. It looks kind of like we're making a function call to the function called fnptr, but it's not the case, because fnptr is a pointer. Content of is the address of getAge. Another way, as you might expect, force in the dereference, just as we do when we dynamically allocate something, we force a dereference.